as you all know that in sand casting, your mold, you can say the mold should have enough strength, and it should have the sustainability during the pouring of molten metal into this cavity. So there are so the main ingredient of your mold is the sand, and your molding sand should have property in order to ensure the quality of the cast product. So there are some important properties of an molding sand, and then you should learn the role of each property in determining or in controlling the quality of your cast product. So the first property is the porosity, and sometimes it is also known as the permeability. So it is the availability of the molding sand to allow the gases to pass through it during the pouring of metal. So during the pouring of molten metal into the die cavity, the gases and steams are generated due to the burning of the binder contents, and as the moisture is already available in the sand and clay, so the gases and steams are generated during the pouring of molten metal into the sand cavity. And you all know that where these gases and steam will go, they will simply try to diffuse into the molten metal, and they will try to produce the blowholes and fine network of the porosity. So this property is very important in determining the strength and the ductility of the cast product. So this property depends not only the shape and size of the particles of the sand, but also on the amount of clay and binding material and moisture contained in the mixture. So you have to select the amount of clay, binding material, and moisture contained in the mixture, so that the mold should have required strength, but it should not have excess amount of moisture and the binding material. So, if you have an excess amount of moisture and binding material in the mold cavity, then during the pouring of the molten metal, the heat will cause the burning of the binding material and the generation of the steam. So these two products will cause the porosity in the cast product. So this is the porosity. Then we have a very important property which is called cohesiveness, and it is basically it's a property of the sand to hold its particle together. So this property is very important in retaining the integrated shapes of the mold, and it decides the strength of your mold cavity. So if the sand is not having the required amount of cohesiveness, so it will lead to the insufficient strength, and insufficient strength may lead to the collapse in the mold particle during the handling. So suppose if you have made a first half of the that cavity, which is your cope, and then what you are doing, you are flipping over the drag part, and if you're trying to mate it over the drag part, so during the shaking and during the mishandling, it may damage the upper part of your mold cavity. So this cohesiveness is a very important property, and clay and bentonite improves the cohesiveness. So clay is basically bentonite and clay, both clay I'm talking about there are basically two types of clay. One is the kaolin clay and other is the bentonite clay. And bentonite clay is aluminium phyllosilicate clay, and the amount of this simple clay, which is kaolin clay and bentonite clay, it improves the cohesiveness. So this is the cohesiveness property of the molding sand, which determines the strength of the mold cavity. Then we have another important property which is called the adhesiveness. And this adhesiveness is the property of the sand due to which the sand particle stick to the size of the molding box. So the adhesiveness of the sand enables the proper lifting of the cope along the sand. So if you have prepared the mold cavity and if it is not sticking to the molding box surface of the molding box, so during the lifting of the cope or the drag, the whole of the sand or the prepared mold cavity, it will fall down and then you can damage the mold cavity. Then we have another property which is called the flowability, or sometimes it is known as the fluidity, but the correct term is called the flowability. So it is the ability of the molding sand to free flow during the compaction and ramming, and it allows the filling of this molding sand into the inaccessible areas or fine details present in the pattern area. So this flowability is very important, and suppose if your flowability is poor, then during the ramming and filling of the mold into the cavity, it will not reach to all other integrated portion of the cavity, and it varies with the moisture and clay content. So flowability can be controlled with the help of moisture and clay content, and flowability also depends upon the size of the sand particles used in making the sand mold. Then we have the collapsibility. So collapsibility is the property of the sand due to which the sand mold collapse automatically after the solidification of casting. So after when the solidification is completed, the sand mold should collapse automatically, so that it will reduce the production time, and the mold should itself disintegrate into sand particles. So with minimum force applied, it means that you should not apply a large amount of force to remove the casting from the mold cavity. So automatically after the solidification, your mold should collapse automatically. So this is the collapsibility. And last property is very important property, and it is known as the refractoriness. So this is the property of the sand to withstand high temperature of molten metal without fusion or softening. So your mold cavity should maintain or retain its shape and size while the metal is poured into it. So this refractivity is related to the ability of the sand to withstand the high temperature. And if molding sand with poor property, it will burn when the molten metal is poured into the mold, and it will become softened. You know that at temperature close to the 1700 degrees centigrade, your sand or your silica quartz, it behaves like a fluid. So if this molten metal is poured, suppose if you are working with the molten metal of steel, if you want to cast steel product, so you can also reach up to a temperature of 1500 degree or 1600 degree, that depends upon the carbon content. So at that time your sand mold should be able to withstand a temperature up to 1650 degrees centigrade, and it should maintain the size, and it should be able to withstand such high temperature of the molten metal. So, if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.